Here's a 3.6 continued. So I'm going to label it B. And we're looking at the numerical values problems. And what we have is FG, F prime, and G prime. We're going to use a table to answer these questions. So it's worth noting that when you're finding the derivative of the inverse when x is 3, that it would be worthwhile for you to figure out what f of what x value would give you 3. And that's really what we care about. So this is, we look at our table, we're looking at f giving us 3 is this x coordinate, which is 1. There's a thought process to what I'm doing, because now I can figure out what f prime of this x value is, which gives me 2. And so by realizing that 1 is what you get for the inverse, I guess so to speak, then this value, let me switch colors, is equal to the reciprocal of this other function. So 1/2 is that final answer. I feel like I should give you sort of a better explanation than just like, hey, this is what you do. So the premise is, if we were to look at f, all right, let's assume it's a one-to-one function, which I don't even know if this person spent the time to realize that it was or wasn't. Because as I'm looking, it goes down to -4. So I don't know if you really spent the time thinking about if the inverse even exists. But let's say hypothetically it did. 1, 3. And then 3, -3. Yeah, definitely not one-to-one if we connect these dots. But at 1, 3, this function has a slope of 2. So whatever the tangent line is, has a slope of 2. So that means it's going like this is your tangent line right here. So again, I'm graphing f, so maybe I'll just make it like an upwards U shape like this. The premise then, and maybe I'll switch colors, that your tangent line is this green color now, is if you were to look at the function that is reflected over the line y equals x, so I'm drawing y equals x for you, well then this point, let me switch back over to that pink color, this point needs to be reflected, so instead of being at 1, 3, it's at 3, 1. And then that curve would also be changed. So let's say the curve looks something like this. Well, what's the slope of the tangent line right there? Well, let's draw it. Would be 1/2. And that's why this rule works. Not necessarily because of that proof I showed you in the previous video, but something along those lines. So let me repeat the process for g inverse of -2 derivatives. So this is really the same thing as saying g of what coordinate would give you -2. So as I'm looking at my g's, where's -2, it's right here. So now we're looking at g of, so x equals 1. Just happen to be the same. So then you say, okay, well, what is g prime of 1? So as I look for g prime of 1, we're looking at this value, which is 1. And so that takes me back up here, and it's the reciprocal, which happens to be the same value. The reciprocal is just 1. I hope that really makes sense. Before going on in the notes, how about we take a break? And I want to point out that there's a lot of extra practice. If you just go to Khan Academy, and I already typed it in, derivatives of inverse functions, and then click the one that is practice. So you can practice these all day. And notice how this is set up. And hopefully I can still draw on this. I think I can. Yeah, just not as nice. Okay, so they give you the function, and they tell you that h is the inverse of f. So as I'm looking at this, okay, well, they tell me that f of -2 equals -14. So it makes sense that they're asking for h prime of -14. because when h is x coordinate is negative 14, its y coordinate is negative 2. And then you can flip it, you know. So what you need to do on a problem like this, it's really slow for me. This is going to bother me. F prime of x is what you want to find first. Well, you can find this derivative by, oh, this is so slow. That's a 3. It works fine with my mouse, but not with my keypad. 3 halves x squared plus 3. It's not going to work for me, I don't think. 3 has x squared plus 3. So what I can do now is figure out what the derivative is. I'm writing with my mouse, by the way, of negative 2. Well, negative 2 when you square it is 4, times 3 is 12, divided by 2 is 6, plus 3 would give me 9. So what does that mean for h prime of negative 14 is it's the reciprocal of that. 1/9. Let me hit check. Nice. Here's another problem, which I don't know if I'll even try to type it out. I think I might just give you the answer. And they tell you that f and g are inverses of each other. There it is. They're inverses of each other. So if we're asking for g prime of 2, okay, well, first of all, what does that really mean, g prime of 2? That's really saying f of some value gives you 2. Okay, so f of what gave me 2? Okay, well, that was f of 9. You might want to just practice a lot of these on your own, just for the record. So I can do these all day. You might still not get it. So f prime of 9, they give you in the table, is 1/12. So what's the reciprocal of 1/12? 12. Nice. Just another one that they can give you these values. G and H are inverses. G of 1 equals 4, so it makes perfect sense that they're asking for H prime of 4. So find G prime first. Well, that's 5x plus 3. This doesn't work bad once you realize that the keyboard doesn't work. And now do G prime of 1. Why? Because you want the x coordinate for G, which will become the y coordinate for H, which is now the x. I mean, it's confusing, trust me. I get it. 5 times, oops, I was supposed to say to the 4th power. But that wouldn't have affected anything because 1 to the 4th power is still 1 times 5 is 5 plus 3 is 8. So the answer is the reciprocal of that, 1/8. There you go. And you can practice these all day long. I'll just do one more with the table. F, G, I wanted to type on here. Maybe I just will point at things. F and G are inverses. Okay, F, G, F prime. So G prime of negative 2. So that's asking that F of what gives you negative 2. That's this value. So it's F prime of 5. Negative 1/2. So negative 2. Okay, I'm going to go back to the notes because I can do these all day. So as we're moving forward, more stuff, except now we're asking for the tangent line. So the first, they're asking for the inverse of this. And so again, I would take a step back for a second and just say, well, what does that really mean? That means g of x is equal to 1. Okay, so I'm looking for g of x is equal to 1. Again, we're assuming that these have inverses, and I think the author did a poor job of writing this question. But it's still applicable, so just stick with me. They'll never give you a problem that doesn't work on that calculus exam. They go through it really, really well. So x equals 3. So the next thing is I would find g prime of 3, which tells me it's negative 2. So what does that mean is that the inverse versus for derivative is equal to negative 1/2. Now be careful here, because as you write the equation of the tangent line, make sure that you are using, so the slope is right here, x minus 1. So I know I wrote x equals 3 over here, but that was for the g function. So for the inverse function, it's the y. And I don't know why I wrote it that way, because you know me by now that I always write it like this, y equals. That's how they prefer you to write it. And again, strongly encourage you to pause the video at any point and write down the notes. Here's another one that's asking you to estimate the value of f prime of 2. Well, if we are estimating something, then it makes sense to do a difference quotient. So f prime of 2 is approximately f of 3 minus f of 1. I'm using these values because they're in the table. 3 and 1 are right here. Mine should change colors. Over 3 minus 1. Well, f of 3, I should use squigglies as well because it's approximate. F of 3, I believe, is 1. Minus 3 over 3 minus 1. So we're looking at negative 2 divided by 2, or roughly negative 1. So based on this, what conclusion can be reached about the function is at least at some point that it's decreasing. I don't know what else they'd be asking for right here. So let me just change colors. How I'm interpreting this question is because we're estimating a value less than 0. I would at least say there's strong evidence. I wouldn't guarantee that is. Because what we found is the secant line, and the secant line doesn't always give us the best picture. So the best answer I could get is there's strong evidence that this is decreasing. I know I'm sounding like a stats teacher right now. That f of x is decreasing at x equals 2. Sorry about that. I think the last one is really the same type of problem. Estimate the value of g prime of negative 1. Well, as you go back to this, we want to look at between negative 2 and 0. So g prime of negative 1 is a rough estimate for g of 0 minus g of negative 2 over 0 minus negative 2. Well, looking at the top, g of 0 was negative 3 minus 2. But again, it looks like there's strong evidence that g is decreasing at x equals negative 1. And let me just show you the answer key because I'm not trying to hide anything from you. He just wrote it like this. I do want to point out, notice how he writes this g of x is decreasing, because I did talk to another teacher that counted it wrong when they wrote g of negative 1 is decreasing. Because g of negative 1 is a point, and points don't really decrease. A function does at particular points. And I know it probably seems like I'm making a big deal out of it, but somebody else did, and I want to bring that to your attention. This is how you want to write it. Again, I would just say that there's strong evidence. I wouldn't guarantee it. And now, again, it's just a poorly worded question. Khan Academy is the way to go if you want to practice more of these. Otherwise, you are ready for your homework.